Alright, let's have a look at the implementation for delete. So, delete will delete an element at a given index in the list. And our prototype will be struct node star delete. You may be noticing a pattern. We're always returning struct node pointer, and that is because, again, we can change the beginning of the list. We could delete the first element of the list, and then the head of the list would have to change, so we have to return it. Alright, struct node list, and then a position. Now, we're treating the position like an index, so it starts at 0, being the first element, and the last element is size minus 1. So, this delete function is going to be slightly more challenging than our last one. So make sure you fully understand what we went through in the last videos. If you didn't, feel free to go back and look at those videos again. Try the code out. Maybe try writing it on your own first and then looking at the video if you need help. And then at the end, make sure you try compiling it just with a blank test file, just to make sure that it compiles. Alright, so let's jump into coding this. I'll copy this prototype and then jump over to our list.c file. Paste that here, and then we'll turn that into a function. And let's get started. So, what are we going to need for the delete function? Well, like before, we are iterating through the list, which means we will need that pattern again, the template, the step 1, step 2, step 3. So let me grab that template. Alright, so I've grabbed our template, step 1, step 2, and step 3. Now, we also have to consider some cases, just like we did before. So here, let's first change the while loop condition. That made no sense. Okay. So I pasted in the template here. Step 1, step 2, step 3. Let's modify the while loop condition. We're going to want to stop one element before so we can delete the node in front of us rather than deleting the node that we're currently standing on, right? So let's use current next not equal to null, while current next is not equal to null. Alright. So that means we have to account for some cases, right? If we're using current next, it means, just like before, we are going to be overlooking the first element. We also have to consider the case where we are deleting from an empty list, right? Really, this shouldn't happen. Delete should not be called on an empty list. But just in case it does, we can return without any harm being done. So let's start by making an index. Let's set that equal to 0. Alright. Next, let's consider the empty list case. If list is equal to null, let's return list. And this one's going to be null, right? But the behavior here is not defined by our interface. Because really, you shouldn't be calling delete with a position that doesn't exist. Alright. Next, let's consider the first element case. Alright. So if it's the first element, the position will be 0. In this case, let's delete the first element of the list. So like we've done before, let's create a temp and make that equal, in this case, let's make that equal to list next. Now why are we doing list next? That's because we are now going to free list, right? Now what does this mean? So we've got a pointer, remember, visualize the diagram here. We've got a pointer to the second item in the list. Maybe the second item is null, but that's okay. We are keeping track of the second value, so we don't lose the nodes. Then we're going to free the first node. And remember, free takes in a pointer, but free knows to go and unallocate the memory at that pointer. So we've gotten rid of list, and now we have our temp, which points to what was previously the second item. That will now become the new first item. And how do we do that? Well, we return temp as the new head. Alright. So we've covered the empty list case and the first element of the list case. Now let's take a closer look at what happens if we're trying to delete an element that has an index or a position somewhere in the middle of the list. Alright. So what we want to do is we want to stop one element before the node that we want to delete. How are we going to do that? Well, if count is equal to position minus 1, now, let's think about this. What would happen if position was equal to 0? Well, then count would have to be equal to minus 1, and it's never going to be equal to minus 1 because it starts at 0 and we'll be incrementing it, so it's only going to go up. But that's okay, because if count is 0, if position is 0, it will be caught by this first element list case. So that's all okay. Now, let's make a temp. And now this one is a bit different, so let's have a look at this. We have struct node pointer temp is equal to current next. Alright, why am I doing this? Well, let's have a look. We free current next, and then current next, that is the deleted one, is equal to temp. So imagine we've got 3 nodes and we're pulling out the middle one and reattaching the 2 on either side. Or you don't have to imagine that. You can draw it out if you like and see what's going on. What we're doing is we've got current, which is the first node. We're grabbing not the middle node but the end node by going current next. Then what we're doing is we're freeing that middle node, current next. And then finally we say current next is equal to temp, which is the third node. And that way we're removing the middle one. So we've deleted it, and now we don't have to go through the rest of the list. We can simply return. We can return list as the new head. So in step 3, we need to add this little thing here. We need to increment the count. So count plus plus will increment that by 1 each time we go through the loop. Sorry, not count, index. So each time we go to another element of the list, we'll be incrementing our index. Alright, we're almost done. We have one more part of this to do, and that is if we reach the end. So remember, if we reach the end of our while loop, that means we must be near the end of the list. In this case, we will be on the last node of the list. So we haven't gone off the end of the list, we're on the last node. So if that's the case, let me put a comment here. So if control reaches this point here, it means that the index wasn't found in the list. And that's an error, right? We are assuming that when the delete function is called, the position is going to be valid. But if it is not, we can give an error. Invalid index to list. And we can say what the index was. That might help with debugging. Alright, and then we can use this function called abort, which will quit our program. Alright. There we go. That is our delete function. Let's have a look at it again. We've handled our empty list case, the case where we are deleting the first element of the list, and if we are deleting any element inside the list. We also have an error message in case we reach the end of the list and we haven't found the position to be deleted. There's one more function we can do, and it's very easy to write. If we want to delete all the elements in a list, how are we going to do that? Let's look at what the prototype will look like. Here I am in my .h file. Alright, and I'm going to write out a prototype for this delete all elements function. So it's simple enough. We are returning a struct node pointer. We're taking in a list, and we're going to delete all the elements. So let's look at how we code this. I'm going to paste in the prototype here. Alright, and this one's simpler than you might think, right? We can actually take advantage of functions we've already written to implement this function. So let's write a comment here. What we want to do is we want to delete elements from the front of the list until none remain. So we'll do that with while list is not equal to null. List is equal to delete list 0. And then finally, we will return list. And note that here, we are guaranteed that list is equal to null. Alright, there we go. That's delete all. Quite simple. But this is a crucial function, because what we need to do is we need to make sure that every time we've malloced, we need to make sure we also free. So when we're creating our lists, before the end of the list, we want to make sure we call delete all. And this will help us avoid memory leaks. That is, where we just end up with many lists building up in memory, many nodes. Alright, so what will that look like in code? Well, let's jump over here to our test list.c. Now I'll show you. All you have to do is, once you're done with your tests. Just call delete all. Test list equals delete all. Now it's always going to return null, but for consistency and for safety, let's make sure test list is equal to null. And that will mean that we can't accidentally access the list even after it has been freed. Alright, so it's as simple as that. And that's, we've done delete and delete all. And now I want to show you one last thing. Let's look at how we can test our functions. So how can we test our prepend function? It's important to test these functions so we know that we've got things correct. It's easy to make mistakes, even if you're quite experienced at programming in C. Alright, so how are we going to do it? Well, we can use our SUMList function that we wrote earlier. Let's see how to do that. Now if I write SUMList values test list, we would expect the answer to be 166. I did that in my head. No, I didn't. Alright, so what we want to do is use a function called assert. Now how does assert work? Assert is like an if statement. It takes in a condition, right? So we have assert here. Now if the condition is false, right, then it will stop the program and say this assert on line 26 was false. So a successful test should return true. We can make conditions so that that is correct. Let's go assert the sum list values of test list is equal to 166. Now, if the elements were correctly added to the list, this test should pass. One other thing, we've got to add a hash include assert.h. Alright. What other things can we test? We could test, well, we've tested our prepend function. We could also test our append function, right? And that's easy enough to do as well. We could take what we've already got and create a new function. Copy and paste. It's okay to copy and paste in your tests. The more, the better. So we test append, add this prototype to the top, and we call that here as well. And let's change prepend to append. It's as easy as that. Alright. Now, just this much alone is not enough to comprehensively test our functions. We want to test the edge cases. Remember, we accounted for those edge cases, but you have to double check that you did account for them. So we want to try appending to an item at the beginning of the list, as in an empty list. We want to try prepending to a list with many values. We want to try all different kinds of cases that you can think of. Alright, so let's quickly run our function. We have our main, which calls our tests, and so everything should work. We've also hash included list.h. Now, to compile, all we need to do is, see, we've got our list.c, list.h, and test list in this file. Go gcc wall where, and then we go list. Let's set the output to be test list, and the input files to be list.c and test list.c. Oh, we have an error. Alright, let me go fix that up. Alright, maybe we can cut this. 138. Yeah, I know. But we have shown GCC in the home computing videos. So What file is that? That is in. Oh no. I've made some error somewhere.
I cough really bad throughout that whole thing.
Oh, I'm sorry.
It's like, oh, I wanted to sneeze so bad. I was like, yeah. Oh, not today, fish, not today. Oh, I can't even move my legs.
Oh no. What did I get wrong here?
If you want to do the next part next Monday. Sure.
Oh no, I called it count instead of index.
Wait, so
Silly me.
first, you can leave. How much are you going to do?
I'm almost finished. I just got to fix this one bit.
So we could do like another part here. Yeah, we did do one. Do the prerequisites.
Oh no, how am I going to fix this?
Okay, do you want to do a summary as well? Are you going to do a summary here?
I've been doing little summaries at the end of each video.
But those are short videos. Right. I don't think you can add a summary to this one.
Yeah. Alright.
The reason why I ask is because we need people.
Oh yeah. No, I don't think we need summaries now.
No.
Sorry. Stop one. Oh no. I wonder if we can do this in post. It's one word we need to change.
What?
Oh no, it'll be too hard to do in post.
Is it for the whole thing? You just do it just the last test?
I put the word count instead of index. It's the wrong variable name.
Show them that and be like, look, I made a mistake. It happened.
Oh yeah, but it'll make the video longer. I don't want to drag it out.
Make it 10 seconds. You don't have to make it wordy. Like, I found my mistake. I just used the wrong count.
Alright, fair enough. Yeah.
Yeah, and then just swap between
them. Alright, so I made an error here. I used count instead of index. Let me just put index there. And now if we compile, hopefully we'll have no errors. Alright, so now we can run test list. When we run it, we get all tests pass. That's a great thing to see. Alright, so that's it. In this video we've covered delete and delete all, and we've looked a little bit at how to test your linked list functions. Thanks for watching.